Okie doke. So, what you guys are going to be doing for next week is Milestone 2. And let me just take a look here. Just to double check when I have it due. Okay. Yeah, so you guys have 1 week to do this. I don't see this one taking as much time as the previous one. And we'll kind of go over why that isn't here in a second. There we go. Okay, so if we look at Milestone 2, which is, oh, I didn't update this. Let's go to the project sheet for it. Wait, what am I doing? No, first we need to go over homework. First we need to go over last 2 assignments. So first up, we'll cover dice stats. And I'll walk you guys through my implementation. So I know some of you use 2D arrays, that's fine. The idea was because you would have just learned 1D arrays, you would have been practicing one-dimensional arrays. So I had several arrays. I had one arrays that was just the different kinds of dices you could have, a D4, D6, D8, etc., all the way up to a D20. And then I had a 10,000 capacity array for each of my different dice types, and I named them accordingly. And I just said, and for each of them, I just did a 1,000 or 10,000 iteration loop where I just populated it using this roll method. The roll method is very easy. Just, next int, and D is like the max that you enter. So the bound is from 0 to the max, not inclusive. So we go D minus 1, and then we add 1 to the result. I can't speak too much to this implementation. This is something I just took from Stack Overflow, and it works. And whenever I need to do something like this, that's usually what I end up doing. I usually don't end up remembering this thing all the time off the top of my head. So whenever I run into an issue where I'm like, oh, I need to generate a random number between 1 and 10, including 10, or yeah, from 1 to 10 or whatever, Java, how to generate random number 1 to n, we'll say, generating random numbers in Java. Here's a good one, Geeks for Geeks. This is just for a random one. Generate number, let's say in range. There we go. Generate random integers in specific range. You can use that the following way. Here's the range, here's the minimum, and this is it. So in this case, this is my range. I forgot why I did the -1, but it did work. +1. Anyways, it generates my data, and boom. I think the other stuff was pretty easy. I know in class we went over how to calculate standard deviation, and I had separate methods for that. I encourage you guys, when you're doing stuff in your program, to really think to how you can delegate the jobs. The analogy I always like to go back to is like an office worker. So your methods are like, you have Jim, whose job is to, I don't know, fill out the expense, to check the expense reports. Then you have Bob, whose job it is to handle hiring, etc. You have all these office workers. And then when we get to classes, we'll talk about how we can further abstract that concept, but I think you guys have just started talking about classes and objects in your 210 classes, right? Like that should have been just this week, and maybe even next week you just started. So I don't want to go too much into that because I'd rather let your 210 instructors take care of that, and then I'll accelerate that. Anyways, any questions about the dice stats lab? It should have been fairly straightforward. I think the most confusing part of it was how I wrote the lab assignment. But if there's any specific part of the implementation you guys want to see or we want me to talk about, please let me know. Otherwise, we'll just move on. Line 57. Okay, this is just, this one is my percent error, and then error 2 is the practical error. So the I mean, I expected, etc. As you can see, these are just rounded down. So, you have to find 2% errors. 1% error was supposed to be like your actual calculated, and then 1 was the practical, in which case I just wrote I mean standing and I expected, which is just int mean, int expected, and yeah. I cast them to doubles here because this should still return a double. I just did it to just be explicit and make sure that it would perform double math properly. But this is not, I don't think this is absolutely necessary. It's just something I did to be very explicit to Java. I'll put a line of space in there. Okay, so let's talk now about the other one, which was tic-tac-toe. So my implementation here is just a 3x3 board. If you did the extra credit, I will probably work on that in the coming week and upload a different video talking about how I went about doing that. But regardless, let's kind of go over it. Oh, I didn't even have a, okay. I thought I had two separate arrays, but I didn't. This was literally just handwritten, me being lazy. You could even put this in like a, I could even do like system or show board numbers. And I'll have a method over here called static void show board numbers. That way I'm delegating different tasks to different places. I don't know why I had you guys do it in an array. You really didn't have to do it in an array. It would have been way easier to do this, so my bad on that one. I just had forgotten about my own implementation. So you guys already saw the output. I have two chars here, P1, P2, and I assign P1 to be the first player, and then somewhere here I do change it. Oh yeah, if turn is even, then current player equals 2. So it means player 2 gets to go first because turn is initially 1. So never mind, player 1 is first. So yeah, we just keep going. For my win condition, and I'm sure this is what you guys mostly wanted to see, I did it the really lazy way. I just said if, like for instance, here I checked for a row, because these are all in the same row, and it's column 0, 1, 2 in row 0. And if they're all equal to the player, the current player, because I check for the win after at the end of each loop. End of each loop, I check for the win and such. Oh, a couple of you were curious about how I converted these numbers, and I'll kind of talk about that here. I was kind of talking about this last week, but I'll go into it again. So if we imagine that we have our tic-tac-toe board, right? And we could also, this is also an array. And I number this stuff 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, I don't know how many of you guys saw my chat with Ethan last night. I encourage you guys in the Discord to go and read through that, because that really breaks down not only how to do this, but how integer math works in Java. Show me with a thumbs up, thumbs down, clap. Thumbs up, you're pretty solid on integer math. Thumbs down if it really confuses you, and clap if you're somewhere in between. Okay. So really, integer math, the best way to describe it is just remember back to your first grade division. Remember back in first grade when they said okay, let's say you have a number 7 and you want to see how many times 3 goes into 7. So how many times does 3 go into 7? Well, 3 goes into 7 once. That leaves 4 remaining. 3 goes into 4. Oh, it's right here. So that's 1. And then 3 goes into 4 once, and that leaves 1 remaining, right? So this is 2 remainder 1. And that's integer math, right? This is when you divide two integers, even if it's not a whole number, or even if they don't, technically this would be 2.33 would be the actual math result of this. But with integer math, you separate it into two parts. There's the whole number, which is the integer, because integers are whole numbers, and then there's the remainder, which is the modulo, which is over here. So in integer math, 7 divided by 3 is equal to 2, but 7 modulo 3 is what? One, exactly. And this is it. This is integer math. It's really basic. It's really easy. So let's erase all this. So if we go back to the original problem, let me look at this thing a little bit. Let's see if we can come up with a formula for, say, 5. Let's just start in the middle, okay? So 5 is an index. Actually, I'm not going to do 5. I'm going to do 8 because the column and row are different. And we'll call this C, and this is R. R for row, C for column. So if we look at 8, and we think to ourselves, first of all, the first thing we have to do here is, are these indexes or are these labels? That's one thing that I really want to talk about a little bit first. Are these indices or are these labels, 1 through 9? Are these indexes for our matrix or are these labels? And there is a difference. Yeah, they're labels. Because remember, index is not necessarily coordinates. Index refers to the position within the matrix, within the list. A label can be whatever. I could have numbered this 2 to 10. I could have numbered this, I don't know, like 3 to 12. It doesn't matter when I number it. All that matters is we have to make sure that an index starts from 0. Index is how, like, the absolute position in the list. The label can just be whatever. So in this case, because our labels start with 1 above 0, here we'll just say 1 is equal to 0 plus, actually I want to make that a different color, 0 plus 1. So because of that, we have 8 minus 1 over here for what I call the I, or the N, whatever you want to call this, quality over here. And then we know that a minus 1 divided by some number should give us either 2 or 1. 2 or 1. And then 8 minus 1 modulo x gives us, okay, the dog's leaving. Sorry, everybody. Should give us 1 or 2. Or 2, and this should be 2 or 1. So think on this for just a minute while I go let the dog out. Yeah, I'm talking about you. Talking about you. Yeah, there's people downstairs. So when he heard him, he's like, oh, well, that sounds more interesting than this. Okie doke. So, does anyone have any idea what we're going for here? What should x be? What do you guys think x should be?
The number of rows there are, so 3.
Yeah, well, x is really just a dimension. So yeah, it's 3 in this case because it's 3 by 3. Or I should say, yeah. This rule I found it works for square matrices. Last week we were trying to make it work for rectangle matrices, so ones that are longer or taller. But the rule didn't quite work out, so I'm still kind of trying to work on that before I look it up online. Oops, should be a line. Okay, so yeah, if we go 8 minus 1 divided by 3, what does that give us? 7 divided by 3 gives us 2, and then if we go 8 minus 1 modulo 3, that gives us 1. So we know that this a minus 1 modulo 3, the modulo gives us the column, and then the division gives us the row. And in any square matrix, regardless of the size, we can use this rule. So let's clear this, and we'll write a general rule for it. So we'll say our general rule is I, and I has to be the index, I divided by n, or we'll just say, just say n. N is our dimension, is equal to the row, and I modulo n is equal to the column. So we're going to say this is our rule. And let's take a look at a slightly bigger matrix just to test this theory. So we'll go with a 4 by 4. 1, 2, 3, 4. 1, 2, 3, 4. And I'm going to label this again from 1 to whatever. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So remember, I is the label minus 1 because, right, we started from 1, which is 1 greater than 0. Is everyone understanding why I'm doing the minus 1? I know I'm like explaining it really poorly, but if you're lost, let me know and I'll try to think of a different way. Otherwise, I don't want to waste you guys' time. Is everyone understanding where the minus 1 comes from? Right. Because if we were doing this by index, if the labels were the same as their index, then it would be 0, 1, 2, 3, etc. Right? Because an index, our indices, which give us the position of elements in a list or a matrix or whatever in our array, they always start from 0. In computer science, we always start numbering from 0. In this case, I started numbering from 1. And if we just use these numbers, they're going to be off for the rule. They're going to be off. So to make it, to get, sorry, I just realized I should like explain why we're doing this to begin with. The whole reason we're doing this is so we can come up with a way to treat our two-dimensional array as a one-dimensional array if it is square. So if both dimensions are the same length, we can treat it as a square. It works specifically for stuff like tic-tac-toe or like any kind of board game. If you played checkers or chess or whatever, you could do this kind of thing. Anytime you want an easier way to give the user in one input to say, okay, which square do you want to put it? And then just label the squares 1 through n or 0 through n. Yeah, exactly, Ronnie. Yes, Ronnie explained it very well. So let's say, I mean, if I started this like with, let's say 2, then I would be like, the I of this first one would be I minus 2, right? Like if this label here was 2, then I would be the label L minus 2, in this case 2. And then if it was over here, would have been 3, it would have been 3 minus 2, and so on. Oops, we don't want to clear. We want to just erase. So that is the reason. What Ronnie wrote out is a really, really important concept to understand. Yeah, and like I said, if it was 2, if I started with the number 2, if I started numbering this, labeling this with 2, then it would be whatever the label is, minus 2 to find I, because I is the index. So let's test this. Let's test the formula we wrote out on, and let's label our rows and columns just to make it easier. 0, 1, 2, 3, 0, 1, 2, 3. And let's do 8. Again, we'll just do 8. So to get our, we're going to say our row for 8 should be 8 minus 1 divided by our n, which is 4, because this is a 4 by 4 matrix. And what does that give us? Nope, 1. Yeah. So our row is in fact 1. And then R, oops, not R, C is equal to 8 minus 1 modulo 4. What does that give us? What is 7 modulo 4? 3, exactly. And it works. Our row is 1 and our column is 3. And if we test it by the theory of induction, if a principle works for the nth case, it should work for the n plus 1th case. So the n plus 1th case would be 9. So row for the 9 should be 9 minus 1 divided by 4, which is 2. And then our column should be 9 minus 1 modulo 4. So what is 8 modulo 4? 0, exactly. There is no remainder when we divide 8 by 0. And once again, it works. Our row is 2, column is 0. And that was how I got 1 through 9. And I remember, I think in the lab I wrote, you don't have to do it the way I did, but if you do, and you do it with switch statements, I will take off points, because I even told you guys that I did it with integer math, not with a bunch of if statements. So if you had something like switch input case 1, put mark at 0, 0, this you would lose points for. You will lose points for that one. Okay, so that is how I check my victory condition. That is how I show the board. This is how I get the rows and columns from the one input, because I asked the user to give me an integer. And I also did a bit of error checking here. We remain in this loop so long as the user's input is valid. And if they give us 0, because I said enter 0 if you want to see the mappings, I check for that over here. If they put in something that's not within this range, then it's invalid. So we say try again. If you guys think back, there was an interesting thing I said once. All you really need for a language to work is our while loops, a way to store variables, and a way to create objects, and a way to write functions. You don't even really need if statements, because you can just use while loops to model if statements. So really a while loop is all you really need. We use if statements because it's cleaner to read and understand, but bear in mind, you can use while in this kind of manner to do some kind of error checking. So that will be something for you guys to keep in mind. Let me know if you want me to kind of go over the logic of this more, but I think it should be pretty self-explanatory. Right? Because so long as either of these cases are true, and it does check both cases, we go in here. Yeah, because if our input is less than 1, or if it's greater than 9, we go in there. Yeah, so right, I said here I have a range of, basically if it's outside of range. Essentially, like if we wrote this out math-wise, basically what I am saying is like, here's the range of input, or of valid inputs. Here is, like, this is, excuse me, 1 to 9. And if our range is here or here, then we go in. But if it's within this valid range, we don't even step into that if statement. Cool. And then yeah, just increment the turn every time. And if we ever have a check, if we ever check for a win and it's valid, we say game over, the current player has won, and then we break out of the loop. And I didn't have one to check for a tie, which is kind of my bad. And I'll say I should say check for tie. I should have another one here that checks for tie, and we can actually code that together. Then if check tie board, because it's assuming there was no win, right? Because if there was a win, we would have broken this loop immediately. And then at the end of the program, I'm going to write a method here called static boolean check tie char board. I don't even need to say that. It's a tie if we're on turn 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If we're on turn 10 and there's no winner, then it's a tie. If turn equals 10 and there is no winner, then I print the game is a tie, no winner. And then we break. And we can actually check that right here. Right, tic-tac-toe. We can run this real quick and just check. One, 2, 3, 4, 5, 7, 8, 6, yeah, so if we get, that one didn't work out right. Hold on one second, sorry. 1, 4, 2, 5, 6, 3, 7, 8, 9. Equal to 9. Yeah, it does allow for that. I'm too lazy to fix that, but that's good catching it, Cameron. 7. If x plus o equals 9. Yeah, that would require me to count the number of characters of each. And I really don't feel like doing that right now. But Nabil, that is another way you could do it, yeah. 5, 8, 9, 6. Yeah. Someone sent it for the thing. The game is a tie. There was no winner. There's a couple different ways I could define this. If you wanted to track the number of x's and number of o's, and if you say the number of x's plus o's equals 9 and there is no winner, like we skip this and then we come here, then we could do that. But I just did it by the turns because that's the quick and dirty way. Obviously, there's ways that I could optimize this program, but I just try to pound it out very quickly. I mean, if I wanted to optimize it, I wouldn't have something like this. I would use a more elegant solution to parse through our array and check. But yeah, that is a tic-tac-toe one. So, what was this deal or no deal one? Maybe somebody doesn't have to fulfill somebody that goes from. Okay, cool. I'll get to this here in just a second. So let's go over what milestone 2 is going to be, because that's what you guys are working on today, or for this week, I should say. Remember, I'm a little more clear here. For your milestone 2, you need 2 things. One, you need the actual code. It should be one file. Or if you have multiple files, somewhere in your documentation, please mention what the main program is. Or no, actually, your main entry point program if you decide to use multiple classes, your main entry point program should be called dungeonexploration.java. That should be the main entry point. And then I want a documentation should be what, let's go with the thing first. Maybe that'll make it easier. So for milestone 2, we're going to convert our maps that we drew from milestone 0, our dungeon maps, we're going to convert that into a 2D array, and we're going to make it fully explorable. So I have over here an example of how my dungeon would work. And one of the things I recommended is you guys use websites like Donjon. I think I have the link somewhere. Oh, apparently I don't. I'll put it in the Discord. I'll put in the Discord the website that I used to kind of get this map random generated. So what I did here, as you guys can see, I just drew a bunch of grid lines. And these grid lines were kind of arbitrary. I just did it to sort of make it like things were fitting in. But this is what I want you to do for your maps, is create this kind of 2-dimensional grid over it and start labeling things inside. So the capital, in my dungeon, my capital E is the entrance, and the lowercase e is the exit. H's are hallways, and then I've numbered all my rooms. There's a few rules. So basically, my player is going to start at entrance, and there's different ways you can go about doing this. For my mini game, what I did was I had a character, like wherever the character was, I placed a P in there, and then I had a method to find wherever P was in the array, and I had another variable that would store what used to be in the place where P was. So anytime the player moved, I updated those values. That way, every time I swap P, I could save what was in the location that the player was in before. So, and let me know if that concept didn't make sense, but I think it should be pretty basic. It's something you guys are doing in the first couple weeks. The idea of using, when swapping variables, using 3 variables to one to be like a temporary holder. So I broke my dungeon down into a 2D array, and it's okay for some of these spaces to be empty. That'll just mean that like it can't be explored, and that is definitely something you'll want to check in your program. So quick question, when I build my array, when I initialize this array, and I don't manually put in any values, what are these empty spaces going to be? What value will they be? What is their initial value going to be for these empties? No. First of all, I have letters and numbers here. What are these? Well, what kind of data type would these be?
Integers?
Well, there's letters as well in the same array.
String?
Char. Well, it could be string, but char will be easier because it's a single letter, it's a single character per, so it's easier to use char. And char can also differentiate there is good differentiating between capital lowercase. You can also do some manipulations with it to get your ASCII codes, which is also another neat thing. But yeah, these are chars. And Nabil is right. These blanks assume that they are initialized to null. Remember, null means no value. Null is different than 0. 0 is still a value. Null just means nothing. Null means empty. And that is a very useful thing to have when we want to query stuff like this, when we want to check if, okay, was this not initialized? So basically my game is my player can move in whatever directions, and I have some like sample prompts here to hopefully give you an idea of like kind of the flow of how my game goes. And do all arrays start at null or just char? Anytime you create a variable in Java, assume that it's initialized to null. Newer versions of Java do this cool thing where they initialize things to the 0 value. So if it's a string, it'll initialize to an empty string, but don't count on it. That's not, you don't know if that's going to be for all the Javas and all Java versions. And I've noticed it can be kind of finicky when it works and when it doesn't work. So it's a lot better to always assume that anytime you declare a variable, but don't initialize a value to it, your compiler will initialize it to null. And null is a value you can use too. You can assign null as a value in some cases, but you don't normally want to do that. Or I shouldn't say you don't normally. I can't think of any cases off the top of my head where I would do that. But just know that null exists, and it's a very important concept to understand. Okay, real quick, what's the difference between initialization and declaration? If I say int x, is this an initialization or declaration? Correct, this is a declaration. And then if I say x equals 5, then it's an initialization because I have initialized some value into this variable. If I go int y is equal to x, then my initialization is in my declaration. So that is something you guys should definitely keep in mind as you write. When you just declare a variable or an object, it's null. By default, it's null. And it's not just for chars, it's not just for ints, it's for everything, including custom objects. Talking about classes and stuff. But that's not pertinent to this assignment. So, right, I have my coordinates, my character moves, and this is a requirement of the assignment. You have to differentiate between hallways and rooms, and you can only move from a room to a hallway or a hallway to a room. You cannot move from a room to another room. So for instance, 5 and 7, imagine that there's a wall here and I can't go between them. It's that way in my map, but even if it wasn't, if they're two separate rooms, and if they're two separate room numbers, I can't go between them. So you'll have to come up with some kind of logic to facilitate that. If an adjacent square is a different number and it's not, if the adjacent square is different and it's not hall, if it's not an H, then I can't cross it. Or sorry, if it's not H or E, then you can't cross into it. Obviously, if it's that, you can go into it. And one of the things you'll notice, these prompts that I have, I try to do my best to, because it's a text-based game, right? The user doesn't have visuals to see your map. I try to, totally spacing. I try to describe the room best I can. So if you ever play Dungeons and Dragons, you're the dungeon master. You just tell your player what's going on. It's your world that you created and you need to explain it to them. You need to describe it. I encourage you guys, if you have friends or family or like someone living with you, after you write it, have them play it and see if they can kind of navigate their dungeon, because they can tell you, hey, I don't understand this part, or I don't understand what's happening here. Because if you look at this, the user experience is just as important as the techniques and stuff that you use, right? It is worth a good amount of points, because ultimately at the end of the day, we're creating a game, and the game should have some kind of nice user experience. It should be fun to play, or it should be interesting to go through. So that is something you guys should keep in mind as you design your game. I highly encourage you guys to spend a lot of time with just pen and paper, kind of mapping out what your dungeon is going to look like before you go into code. Is each room restricted to one element in the matrix, or can a room be made up of multiple squares? Multiple squares. Yeah, it can. Like for instance, here 5 is 2 squares. If you're here and then you go here, you're still in room 5. And however I've described room 5, like let's say I said, you're in a big room. This is where you can use switch statements, by the way. You can try this statement. You could think of logic to build these. Do you remember the, let me go back to the Mad Libs demo that we did. Where is it? Wait, did I do the Mad Libs demo here? Oh, it's command line args, thank you. Yeah, so here remember we have the Mad Libs demo? You can use something like this to try and dynamically build like your dungeon master description. That's how you should go about doing this assignment. To answer your question, Cameron, yeah, rooms and hallways can take up multiple squares. That's the whole point. Like if you look at this one over here, this segment over here, I want my user to start in room 2. So the top half of room 2 is the entrance, and the bottom half is the actual room. And if the matrix isn't like 100% on board with your initial map, that's okay. No, this one, you don't have to do any combat. If you want to describe it as a villain in a room, that's fine. But ultimately, the mechanics for this portion are just the user being able to move northwest, south, or east. So only vertical or horizontally moving their way, trying to get to the exit. So for my dungeon, they'd have to go here, then here, then here, then here, and take all these hallways over here, get to this room and go here. Or they could turn left, come to this room, come down here, down here, down here, and be like, oh, hey, here's the exit. Right? Actually, yeah, I'll double check that. I may have said you can only go from a room to a hallway, and your E's might count, your lowercase e might count as that. But if I didn't, then it's fine. Really, the main rule is you can't go from one room into another room. Like, this movement is not allowed, and I will not present this option. You should also tell your user which directions they can move in. Like, for instance, in the prompts here, I said the user can only move south or east. So when I ask them where they want to go, I tell them you can move south or east, right? Because they can either go south or they can go east. They can't go north, they can't go west, because it's out of bounds. Does the movement have to be directional? It's going to be much easier for your user to understand what's happening if you say go south, west, east. Because then if you tell them go left, go right, then you have to consider, okay, which way were they facing when they came in, and you don't want to deal with that mess, right? How about just rooms? What do you mean? Room names. The idea of the room names, the numbers, is it's supposed to be more of an internal tool. The idea should be that you should be like, you're in room 2. Okay, let's go look at the table and see what room 2 is. So you should have like kind of like what we did for the Mad Libs, something here where you build the description of the room, right? So when it goes to room 2, it'll be like, okay, let's look at the room name and let's see what's in here. Let me just show you the website. So if I generate a random dungeon here, and I'm like, okay, let's go look at what room 4 is. Okay, here's all the things that are in room 4. Here's the features of the room. Here's what it looks like. Here are some of the different things that might be in this room, etc. Your game for the exploration should work similarly. It should have some kind of table internally that it refers to know how to describe the room to the player. And this assignment just designed for our dungeon, or do we also have to consider any traps, obstacles? For now, just consider movement. Traps and such will be later. So it would be bad if we have multiple states of being in the same room hallway, such as the north half of room 5 and the south half of room 5. No, you can do this. This is okay. This is okay. You can move between rooms so long as they're the same number. But if you're going to move from a room to a room that's a different number, that's not allowed. There should be a wall preventing you from that, right? So when my user is here, the game is going to tell the user they can go north, south, or west, but they can't go east. Here, the user can go north, south, east, or west, right? They can move in any direction from this portion of the hallway, according to the rules of our game. Does that make sense? You can have rooms that span multiple squares. That is okay. But remember, the array that you create should have a minimum of 5 rooms, because that was one of the requirements of the assignment, is that you have a minimum 5 rooms to explore. I have 1 room, 2, 3, 4, 5. I have 6 rooms. So that should be it. When they come here, they should be like, okay, you moved south. The entrance is north of you, so you should have conditions that check, okay, is this the entrance or the exit? because that should be described to the user where it is relative to them. So yeah, there's going to be a lot of logical checking. You're going to have your game loop that kind of traverses this. Yeah, you're going to be putting together a lot of the stuff that we've learned thus far to make this happen. Any questions about the assignment? And I will go over, I'm trying to remember why I wrote the deal or no deal one. Oh yeah, I wrote this so you guys can kind of see how you can create prompts and stuff dynamically. So let's run deal or no deal. The game is very simple. You're just told to open a door between door 1 through 7. Did you already check the Milestone 1 resubmissions, by the way? Yeah, I already went through and regraded them. So your grade on Milestone 1 is your final grade. If I say 0, then it says, hey, your input is outside the range. And if I say help, it'll give me like this little help prompt over here. So let's say we pick door number 5. Okay, so behind door number 5, there was a super dog. Congrats, game is over. That was it. It's a very, very short game, but it was just to give you an idea of some ways that you could represent your different rooms in your dungeon, right? So one of the things I did here was like I passed in what door number they picked, and then I said char doors, which is just this. Are we restricted to a 2D map? Yes. Please do a 2D map. I know some of you have like very unique designs for your dungeons. Try your best, if you can, to model the exploration of the 2D map. The idea is that you should have like a beginning, like an entrance and an exit point for the dungeon. I think moving forward in future classes, I'm going to be a lot more strict about it being strictly a dungeon crawler. I know I allowed a bunch of you guys to, like, if you had a really good idea and you thought you could pull it off, and I thought it was doable, I said, sure. Some of the milestones might be wonky for you guys, but yeah, I think moving forward, I'm going to be more strict about what you guys can build. Like, it has to be a dungeon crawler. Cameron or anyone else, if you have questions about your specific implementation, message me and I'll see about helping you guys and how you can adapt that into this. If you think you can make a 3-dimensional array work, or more than dimensions than that, if you think you can make it work and you can describe where they're going and what there is, go for it. Yeah, sure, Zizo, I'll take a look at it after class. But again, I think you'll have the easiest time if you just do a 2-dimensional array, because it's very easy to envision just a flat board. You could try to do it with the 3-dimensional coordinates. Good luck to you. That will be your can of worms to open, because the specific one for that is going to be, how do you define which direction they go? It's very easy to use the cardinal directions, north, south, east, west. It'll be a lot harder to describe to a user polar directions. So, if I can't understand it, you're going to get a bad mark on your, what do you call it? I'm thinking of just multiple floors, levels of the dungeon, stuff like that. For now, just assume your dungeon is 1 floor, okay? I get what you mean by that. For now, just assume that it's 1 floor. And you can make that 2D array as big as you want. So if you have multiple floors, just put it all on one. Any other questions about the assignment? If there are no other questions, I'll stop the recording and that'll be it for today's session. Will we have an extra week to work post-submission? I haven't decided yet, because we're coming up on the end of the semester and there's still 1 or 2 other milestones to do before you build the final game. So assume that it's due next week. That's why I highly encourage you guys, don't wait on this. Don't waste time. You know, you might be okay if you take it easy over the weekend, but like Monday onwards, you have to hit the ground running with this. Because I don't know if I'm going to give an extra week or not. Assume that I'm not. And if I do end up giving an extra week, great. Do we need to implement the combat loop? No, just the movement. This is just isolated to just the movement. We're isolating different parts of the game now because what's going to end up happening is when we move on to objects and classes, you're going to start combining pieces together. You're going to start combining combat with item discovery, with, with the exploration. Can you go over the chapter 9 pre-lab instructions? Sure. Thanks for reminding me. Chapter 9 pre-lab. Objects and classes. I didn't write anything for this, did I? Because chapter 9 pre-lab right now is just you going off and really don't like having you guys just read the book. I think what I might have you guys do, you'll just build Old McDonald's farm. Actually, I have to think on this because I got kind of turned around this week. Just do the book. Yeah, just do what the chapter 9 pre-lab has you do right now. Read those sections and play around with it. Play around with the code. The instructions on there are pretty clear. Practice the code samples from the reading in your own IDE so you understand how the objects and classes work in Java. When you are done, describe how you can use objects and classes in one of the previous labs to make your code easier. Describe how your code would be more efficient that way. Write your answer in the submission text box. So, for instance, for the combat loop, using multiple classes would have made that one a lot easier, for instance. Because if you think about it, you had multiple character objects. You had the player and the monster. And you could have used the same object to describe both because they both had a name, they both had a max health, they both had a current health. They both shared a lot of traits, so instead of having like 8 different variables to describe both players, you could have just used you could have used just one class and instantiated 2 different instances of it. So yeah. Just talk about it, I guess. Talk about what you understand about classes. Ask me questions. If you have questions about classes and objects, please ask them in there because the next couple of weeks are really, really important for you guys to understand. And I have to make sure I describe the stuff in a way that it reaches because this is one of the other snags that students hit. When we get to objects and classes, some students will get totally left in the dust because it's a very different way of thinking about stuff. So throughout the week, if you have questions from 210, make sure you jot them down somewhere. Your pre-lab assignment, like I said, is to talk about how you could use objects classes in different labs you've already written and how it would make it more efficient. Even different assignments. Tell me about, like, if you had a different assignment in 210, you're like, oh, well, with classes and objects, we could have made that way, way easier. Write about that. Obviously, if you do that, explain what the 210 assignment initially was and how you implemented it. That way I have some background. Otherwise, like if you just tell me, oh, for assignment number 2, I could use classes to make it more efficient. If I did this part with the class, it would be more efficient. Like I have no idea what assignment 2 is. I don't know what you have to do for it. So make sure you explain that. Does that explain the chapter 9 pre-lab instructions? Cool. Okay. If there's no other questions, I'm going to stop the recording. So going once, going twice. And then we're done, I guess.